Good morning, geometry. For your problem today, your warm-up problem today, I sent you this and asked you to find this length right here, which is 5.6. Probably it took you about 4 or 5 steps to do it. You probably dropped a perp and then worked some magic in there and then finally got your X. And boy, wouldn't it be great if there was some kind of a shortcut or a formula. So that's what we're going to investigate today. But before we start to look for that, let's look at the information that we had and what we're looking for. The information that we had were 2 sides and a contained angle. In other words, we had a side angle side situation. And what we were looking for is the side that is across from or opposite of the angle that I know. All right, so let's see if we can generalize this bad boy. So let's say I've got this triangle here. And let's say that the things that I know, I'm going to mark in green. Let's say I know this side right here. I'm going to call that B. Let's say I know this whole side right here. I'm going to call that A. Let's say that I know this angle right here, angle C. And let's say that the thing that I'm looking for is the side that's across from that angle, side C. So I've got a side angle side situation, 2 sides and an angle contained, and I'm looking for the side that is across from the angle that I know. All right, so just like we've done so many times before, the thing that we're going to want to do to get started here is to drop a perp. And when I drop that perpendicular, I see that now I've got 2 right triangles. I've got a right triangle here and I've got a right triangle here. I'm going to call this length right here H because I don't know it. And you know, I could work some trigonometry. The problem is that I've only got 1 angle on this one. I don't have any angles over here, so trig might not be my best way to go. I think I'm going to go back to my old friend Pythagoras. All right, so if I want to write a Pythagorean relationship, don't I need 3 sides of a triangle? And I've got 1, 2. I don't have this side here. So you know what I'm going to do? I'm just going to, for right now, call that guy X. And I'm looking at this triangle. So I could write a relationship. X squared plus H squared is equal to B squared. Now keep in mind that this whole length right here is A. So when I go to look at this triangle here, I know the hypotenuse, or I'm looking for the hypotenuse. That's something I've got labeled. I've got this side here labeled. I don't have this side here labeled. But if I know this whole thing here is A, and this much of it is X, then this much of it from the foot of that altitude to vertex B is A minus X. So now I can write another Pythagorean relationship, that A minus X squared plus H squared is equal to C squared. That looks pretty good to me. You know, I see that binomial squared and I really want to square that bad boy. And I know how to do that because we've talked about it in class, and don't break my heart, you still know how to do it. A squared minus 2ax plus x squared. I'm going to copy the rest of that. Okay. And now this is where it gets really, really, really cool, because look at this here. And look at this here. Oh, I'm going to substitute in b squared for that. A squared minus 2ax plus b squared is equal to c squared. Well, that looks kind of nice. So if I look at this, I've got an A. That was something I knew from my original problem. I've got a B. That was something I knew from my original problem. I've got a C. That was something I wanted from my original problem. The only thing is this X. That wasn't something I originally had. So let's go back up to our picture. Is there something I could do to find that X? Well, I'm going to look back to this here and remember that I still knew that angle there and I haven't used that information yet. Oh, look, in relation to that angle, I know I'm looking for that adjacent side and I know that hypotenuse. Seems to me like I could write a cosine relationship. Cosine of angle C is equal to x over b solve that for x. X is equal to b times cosine c. Now I'm going to take this value here and substitute it in for that x right there. So a squared minus 2ab times cosine c. That's what I substituted in. Plus b squared is equal to c squared. So the only thing I've done here is I've taken this right here and dropped it in for that x right there. And now I just want to clean it up just a little bit. I'm going to commute my terms around. I'm going to bring this plus b squared to have it socially distancing it at 6 feet away, but hanging out with its buddy a squared. A squared plus b squared minus 2ab cosine c is equal to c squared. When I look at that, a, that was a length I knew in my original diagram. B is a length I knew in my original diagram. A and B are two lengths that I knew in my original diagram. Angle C is something I knew from my original diagram. And the C, that's something I was looking for. Looks to me like I got myself a formula. And you know what? It's even better than that. It's not just a formula. It's the law. Dun, dun, dun. This bad boy right here is called the law of cosines. All right, so now here's the thing. We're not always going to have the letters A and B and C, and they're not always going to be in the places you want them to be. So let's go back to the original diagram and look at what are A, B, and C, angle C and side C, in the context of the problem. I have two sides. That's my A and my B. Okay, so this is a side squared plus another side squared minus 2 times the product of those two sides times the cosine of the angle that they contain is equal to the side that is opposite squared. Okay, so, I can I could work with a totally different picture here and use totally different letters even. I could say, hey, I don't even have to use letters. Let's say I use some numbers here. Let's say this is 29 degrees. Let's say this is 17 units. Let's say this is 23 units, and I want to know this, okay? I don't even have any variables, any labels in here at all. So how am I going to use my law of cosines? Well, let's keep in mind, the A and the B are two sides. So I'm going to start out by 17 squared plus 23 squared minus 2 times A times B. So 2 times 17 times 23 times the cosine of that angle that's contained times cosine 29 degrees is equal to that c squared. That was the side that was across from the angle that's contained. So is equal to x squared. And now you just got to put this bad boy right here into your calculator. Okay, use parentheses if you feel like you need to. 17 squared plus 23 squared minus 2 times 17 times 23 times cosine 29. Hit equals, take the square root of it. And what I'd like you to do for today, 2 things. Go back and watch this video a second time. Make sure you understand it. Then I want you to go back to our original problem from today. Redo that using the law of cosines and confirm that you got the same answer. And then I want you to enter into Canvas the value of x so that I know that you watched the video and understood how to put that into your calculator. Tomorrow we will do some more practice problems. And in the meantime, you can say hi to my dog. Hi, Max. Maxie. Oh, good boy. 1 Labrador. Ha!